Okay, so we already saw that below the mean there is going to be 50% of our data, and above is going to be 50% of the data. And that makes sense because that point is both the mean and it's the median. So we should be happy that the median splits our whole distribution into half, or into halves, with 50% being above that value and 50% being below. There are some other values that we do need to be confidently aware of, and they are as stated. So we can identify where the mean is. Up to now, we've been using X bar because that is the sample mean, but we are more going to use mu, which is the population mean. All right, so mu just indicates where the mean is, and we're familiar with the standard deviation. I'm going to say that this point is mu plus 1 standard deviation, and this point is mu minus 1 standard deviation. So in this range here, there's a specific amount of data, and that is 68%. 68% of the data for any normal distribution exists within 1 standard deviation of the mean. Okay, so this is 68% of the data. We can carry on from that and actually say, what about within 2 standard deviations? Well, within 2 standard deviations, so this whole area here, we're going to have 95%. Okay, and within 3 standard deviations, we'll have 99.7% of the data. Almost all of the data is going to exist within 3 standard deviations. We're going to get 99.7% of the data existing between there. It is almost all of it. I only have 0.3% left beyond the 3 standard deviations, but just be careful that the normal distribution, actually being continuous, goes on to infinity, positive infinity and negative infinity. So technically there is still area that exists to the left and to the right. A very small and negligible amount of area, a very small and negligible probability, but it does exist, and it's important that you understand it's actually there. All right, so these values, 68%, 95%, and 99.7%, these are values that you need to be extremely confident with and to know that they exist within a particular amount of standard deviations. Okay, and those can be seen a little bit nicer on this diagram. Okay, and those can be seen a little bit nicer on this diagram, where each of the segments are split up into 34% and 34%. Above and below the mean, and then these 14% in between the 2 standard deviation and the 1 standard deviation markers. How we're going to start to find probabilities for different probability statements. All right, firstly, let's get into some notation. Whenever we do set up a normal distribution, we say that X follows a normal distribution for a specific value of mu and a specific standard deviation. We always write the standard deviation squared, which is actually the variance. This is just a convention. You need to get used to it. Always write that as the standard deviation squared. Be on the lookout for questions where they've given you a value of the variance. You would still need to write that in the form of the standard deviation squared. Okay, so this is the general form of the normal distribution. Let's see if we can start to answer some specific questions. So, if X followed a normal distribution of 10 with a standard deviation of 2. A few questions we should be able to respond to. What is the probability that X is less than or equal to 10? Okay, well 10 is the mean, so the probability is less than or equal to the mean, 0.5. Okay, what is the probability that X is less than or equal to 12? All right, so being really careful here, 12 is the mean plus 1 standard deviation. So I know I'm looking for the area below this particular point. So the mean plus 1 standard deviation is all the area contained under here. I already knew that everything on this left-hand side was 50%. Now I just need to add on this extra 34%. So the probability that is less than or equal to 12 for this particular normal distribution, 0.84. By recognizing how many standard deviations we're working with, we can use some of these standard probabilities to go ahead and work out our answers. What about the probability that X is greater than or equal to 12? Once again, 12 is 1 standard deviation above the mean. So this is the important value, and I'm looking for everything above here. It would also be smart to recognize that it was everything that I didn't include in my previous answer. So 0.16. Okay, let's see if we can ask some slightly different questions. What if I wanted to know the probability that X was in between 8 and 12? Well, 8 is 1 standard deviation smaller than my mean. If you like, I can write it out like this. And once again, we should recognize that since this is the mean plus and minus 1 standard deviation, I'm looking at this area here, this region, which is the 68%. Okay, so by making use of the 68, 95, 99.7 rule, we should be able to answer quite a few questions. So on this one, it's 2 standard deviations below and 1 standard deviation above. So this is the region I'm now looking for, and it's 0.82. Okay, be fully aware of this rule and how it can be useful in finding out probabilities, as long as we think about these values in terms of the number of standard deviations they are away from the mean.